All right, so now we're going to assume that you do not actually own the calculator, nor were you able to download the proper software to do it right, um, which I strongly recommend you try again on because TI has opened it up again. But you start with the same information. So we know our first sample's mean was 80, our second sample's mean was 74. We have 5 and 6 as the sample standard deviations. Our sample sizes were 26 and 32. We know our alpha is 0.05. And in the previous video, I showed how you would calculate the degrees of freedom. I'm not going to go through that again because that was terrible, and I don't wish that on anyone. So instead, if you would like to figure out how to calculate that, we'll go back to that. That'll come up here in a little bit. So first of all, the formula for the critical T is right here. It's the mean subtracted from each other divided by the standard error, essentially. The square root of the sample standard deviation for the first one over squared over n1 plus sample standard deviation of the second one squared over the sample size of the second one. So we can just plug these numbers in. So that would be 80 minus 74 on the top. That's divided by, I'm going to play a little fill in the blank here. So this would be 5 squared over 26, and this would be 6 squared over 32. So that's essentially plugging it in. Again, we're assuming you don't have a calculator, so you would just have to use a for function to go through all this. So 25 over 26 plus 36 over 32, square root of that, and then all of that, so 6 divided by that, essentially. Not too terrible, but when you do all that algebra, that boils down to the critical T being equal to 4.15, just like it was before. Now, the degrees of freedom, we said were 55. So what we have to do is on the degrees of freedom row, we try to find 55. Again, we know that there's not going to be any 55. So we'll go to the next lowest value down on 40. And then what we go to the right until we find a T that matches what we're looking for. Now, on my chart, mine stops at 0.001. I don't have any more, right? I don't know if you can see that. There we go. Sorry. I don't have any more. Like there's no further I can go. 4.15 exists somewhere over here. So since we don't have that, we know that the p-value, well, I know it's at least less than this number, since I'm doing a two-tailed cumulative probability. So it's less than that. So I know the p-value is less than 0.001. Now, if something is less than 0.001, we can safely assume that it is also less than 0.05, so we'd still come to the conclusion that we would reject our null hypothesis from this. And that is the hard way of doing it. Still didn't take very long, but basically you just have to use that formula and then use your t-table. Great job.